Good morning, Mary C. Williams friends. This is Miss Britt here. Please join me on page 115. Today is May 29th. This is day 36 of online instruction. So I wanted to go over with you how to add and subtract mixed numbers. Now I'm going to review this really quickly, but I'm going to get into how we are going to do this. So find the sum. You know the sum is the answer to a what kind of problem? Perfect addition. You want to add the whole numbers and add the fractional parts. So these are mixed numbers. These are mixed numbers, and we are going to be adding and subtracting them. Now, this starts out with you adding the whole numbers. I say, no. Do not start there. Don't ever start there. Always start with the fractions. So start here and then do that second. So first we're going to add the fractional parts, and then we're going to write the sum as a mixed number so that this is very important, so that the fractional part is less than 1. I'm going to talk to you about that. So let's pause on the top and let's do our first addition problem. So today I'm going to do one addition example and I'm going to do one subtraction example. Your job is to do number 3, 4, 5, 6, 7, and 8 and send us your answers, okay? And we would like to see your work. So just like they used area models up here, I'm going to show you using area models. So here's my paper, and I've already set it up so that you don't have to wait on me to draw those. So we are going to be doing, make sure you can see everything. 3, number 1 says 3 and 4/5. So 3 and 4/5 plus 4 and 3/5. Now they used circles up at the top, but you know that I prefer to use rectangles. So I'm going to show you what the first fraction looks like. 3 and 4/5. My denominator is 5, so that means everything is going to be broken into fifths. So I have 1 whole, 2 wholes, 3 wholes, 3 wholes, these are my wholes, and this is my fraction. 3 wholes and 4/5. 1/5, 2/5, 3/5, 4/5. That's what that fraction looks like, what this mixed number looks like. It's 3 wholes and 4/5. All right? Now this one looks like 4 wholes, and again, my denominator is 5, which it has to be. These denominators have to be the same so that we can add. So I have 4 wholes, 1, 2, 3, 4, and I have 3/5. 2, 3. All right. So in order to add these fractions, you have to start here. So start in the fraction, start in the fraction column. So we're going to start here. My denominators are the same, so my denominator is going to, stay the same. And I only worry about adding the what? Perfect numerators. 4 plus 3 is 7. And then before I go on, I have to ask myself, is that written correctly? Well, no, it's not. It looks like what we were doing yesterday whenever we were changing a fraction that's greater than 1. This is a fraction greater than 1, or some people call it an improper fraction. So this is a fraction that's greater than 1, so I have to change this. In order to change this, I have to use division. Remember, when the numerator is bigger, you use division. Or, since I have my models over here, I could just say, well, I have 4/5 here and 3/5 here. If I took one of these fifths and I moved it up there, then that is now 5/5, and this is 2/5, and we know 5/5 plus 2/5 is going to give us the same thing as this, which is 7/5, but this is already equivalent to what? Perfect, 1/2. So 7/5 is the same thing as 1/2 and 2/5. Now you can use division. You could have done 7 divided by 5. It goes in one time. 1 times 5 is 5. 7 minus 5 is 2. 1 is my whole number, 1/2. I have a remainder of 2. And my denominator is 5, and it's going to stay the same. So I could have done that. But either way, you have to change this. It cannot stay like this. It has to change. Do not leave a fraction like that, which is a fraction greater than 1. All right. So once we do what we need to do in the fraction column, then we just add the whole numbers like you normally would. 3 plus 4 is 7. But we can't leave it as 7 and 7/5 because 7/5 got changed to 1 and 2/5. So now I need to take my 7 and add it to my other whole. So my final answer is 8 and 2/5, which you can see, final answer, you can see that if you look at our models. 1 whole, 2 wholes, 3 wholes, 4 wholes, 5 wholes, 6 wholes, 7 wholes. We took this piece here, we moved it up there, that made our 8th. So this is 1, 2, 3, 4, 5, 6, 7, 8 wholes, and that one's not there anymore. 1 2/5, 8 and 2/5. That's why I like to use area models, because it helps me to understand. So there's your first addition problem. Now I'm not going to go back to the top. I'm just going to talk to you about subtraction now. So I'm going to do number 2 with you, which says, "7 and 2/3 subtract 3 and 1/3. So we have 7 and 2/3 subtract 3 and 1/3. So we have 1, 2, 3. Remember, my denominator is 3, so everything's cut into thirds. 4, 5, 6, 7, and 1 2/3. All right, we also have 3 and 1/3. 1, 2, 3 wholes, and 1/3. Now the same thing is true over here. When you are doing subtraction, when you're doing addition, it does not matter. You need to start in the fraction column. So we've been doing this. We know 2/3 minus 1/3, their denominators are the same. So I just bring the denominator down. 2 minus 1 is perfect, 1. And over here, that would look like, if I need to take this 1 away from those 2, I'm just going to exit it out, and I'm left with this 1/3. That's what I'm left with, 1/3. Okay? Up here, we have 7 wholes subtract 3 wholes. So I'm taking these 3 away. So take away, take away, take away, take away, take away, take away. And I am left with 1, 2, 3, 4. So this one was super simple because we did not have to regroup. You will have to regroup next week, but right now we decided to start out simple where you wouldn't have to regroup with subtraction because it's a very hard concept. Up here, you just have to know that you can't leave. So when you add your fractions, if you get a fraction greater than 1, it cannot be left like that. It needs to be regrouped or exchanged into a whole number and a fraction, which makes a mixed number. All right, my friends, those are my 2 examples. If you have any questions, please contact your teacher. We would rather hear from you and help you than for you to practice wrong. Thanks so much.